Okay. So today, again, we're going to talk about soil health, but really more than soil health, it is the role of carbon in crop nutrient management and in soil health. And I hope that it's a very practical presentation that we're going to go through this webinar, and that more important, all of you learned really something about it today and that you guys can put it in action. So that's it. Let's just dig into it. So why carbon? That is the first question. Why carbon? And again, we hear a lot about carbon nowadays. We hear from it, again, a lot of companies are now really digging into carbon. I mean, Midwestern BioAg has been talking about carbon and sustainable agriculture and biological farming for a while, but now it seems like it's kind of like the new buzz thing, the new buzzword and the new thing, carbon. To me, it has to go really to a practical standpoint, to a practical point of view, and that's what we're gonna pretty much cover in this webinar in this topic. Why carbon? Really, why we're really interested in carbon and why I'm really interested in carbon in this webinar, it is because it's about biology. Carbon is gonna feed biology, which at the end is really what we're looking for, that is the key. And then why is that important? Because that biology is gonna deliver those nutrients to a plant. So biology is gonna transform nutrients from unavailable forms to plant available forms. And really, that's why it all matters. It matters to feed that biology. It matters to add carbon because we're going to get more nutrients into the crop. And that's really what we're all about. I always say that we, in agriculture nowadays, it's about the big five. And kind of like I'm not referring to hunting, but kind of like hunters talk about getting the big five. That's all we do in ag nowadays. We talk about NPK, calcium, and sulfur to an extent, and micronutrients as a part of it. But really, those are the big five. Everybody in their farming operations every year, the struggle is to get more of this big five into their crops and increase their plant performance and yields. So again, NPK, for those hearing us through the phone, the big five is nitrogen, phosphorus, potassium, sulfur, and calcium. And really those are the big five that we try to improve one way or the other, better sources, better timing, better products, etc., to get them into the crop. Well, as we dig and learn more about these big five elements, nitrogen, phosphorus, potassium, calcium, and sulfur, they're all biology driven. So in this next slides, what I do, and again, I'm gonna try to be very, very verbal and explicit to explain to those joining us via phone. In this next slides, what I do is just go through the element cycles, and more than getting really technical and really about cycles themselves, what I wanna cover is really the biological side of it. So first we start with the nitrogen cycle, and there is a big biological component in the nitrogen cycle. Fungal, bacteria, the bacteria decomposition of nitrogen, transforming nitrogen from NO3 to NH4, etc. So it's a lot biologically driven, the nitrogen cycle. When we switch to the phosphorus cycle, same thing. We see a lot of phosphorus, a lot of fungal activity that transforms phosphorus of making it available for the plant too. So it's the same thing. We have a lot of biology-driven biology-driven transformations that happen in the phosphorus cycle. Potassium, same thing. We get a lot of transformations in the soil. Microorganisms make a huge, play a huge role, make a huge part of transforming that potassium into available form for the plant. So again, biologically driven cycle. The sulfur cycle, which again, now the whole agronomy world is really into sulfur and better sulfur sources. Well, we tend to forget that sulfur has a lot to do with biological activity, and biology makes all that sulfur more available. And finally, calcium too. Calcium is biology driven. It's biologically, biology makes it available for the plant. So again, the big five is biology driven, and this is why carbon plays a big role, and this is why we're going to add carbon to the equation, because adding carbon feeds soil biology, which will make the big five, NPK, calcium, sulfur, more available to the plant. So I always say that the key is to treat carbon like we treat the big five. I mean, we have been really good at managing that big five in terms of, let me go back. We have been really good at managing those big five in terms of the short term and the long term. So let's just think about potassium or phosphorus. We always think about the long term as building up the soil levels. And we're really good at that. And we know we got to increase the P soil levels, the K soil levels, the available nitrogen soil levels, the calcium soil levels. So the long term, we're really good at managing those big five. And same thing in the short term. We know we got to add a little P, a little K, a little N, sulfur, make it available for the plant. Well, carbon, we got to manage it pretty much the same way we manage the big five. So we got to really start working on managing in a way where we manage for the long term and where we manage also for the short term. So how we do that, that's what's key to me. And that's where it really comes into how we manage carbon for soil health, how carbon is important for nutrient uptake, nutrient use efficiency, and nutrient availability of that crop. So when we talk about long-term carbon, it's really the stable forms of carbon. And then that's where we have the carbon pools, organic matter, CN ratios, organic carbon, available carbon really. So that's the more stable part that we're really trying to raise in the long term, 2, 3 years, 10 years. And that is that long-term goal. Same way we manage phosphorus, potassium, and then we think, hey, I want to increase my levels. I want to improve my ratios. The same way we got to do the same thing with carbon. And then there's the short term. That is rapidly available carbon. And we got to manage for that too. Same way we manage the big five, we got to manage that carbon short-term availability. And really the trick there is going to be feeding biology for this year's season. So you got to manage for that 2, 3, 10-year forecast of carbon, but you also got to manage for this year, trying to enhance that biology, trying to feed that biology, and trying to make nutrients way more available than the way they are in the soil and for the plant. So the key there in that short term is going to be really quick available carbon that is going to fit this year's crop carbon needs, and then kind of like go from there. We know that crops remove a lot of nutrients, and we are usually pretty good at calculating NPK, calcium, sulfur removals. Well, crops also take a lot of carbon out of the equation. And more than anything, they take available carbon out of the equation. We need to account for that, and we need to actually manage for that. So that's where short-term carbon actually helps us to bringing back those rapidly available carbon pools that the crops are taking out. So we're going to talk about long-term carbon first. And my biggest thing with this one is organic matter, because we've been talking about long-term carbon related to organic matter. It has been really the talk for the past almost like 20 years. We relate carbon to organic matter. And then we tend to think, hey, I need to increase my organic matter. And that's my measurement. I'm going to try to increase my organic matter, double it in 10 years or 5 years, or increase 1 point in the next 2 years. And we measure everything we do about carbon, every addition we do, from compost to tillage to no-till to any practice we do that if we think is going to have an effect on carbon pools, we measure it by measuring organic matter. And I think that's one of the biggest things that we need to start thinking about. Are we doing that the right way? Do we need to start changing things? So that is probably one of the first things we want to address. And the way I'm going to address that is by putting some case scenarios about that long-term carbon effect and how we think usually about organic matter being the driver for that. So highest organic matter. This is a pretty common case scenario that we have all around the Midwest. And what we have is 3 different crop farming rotations. So again, 3 different rotations in Midwest farming. So one is going to be, option A is going to be wheat, winter wheat, corn, soybeans, 3-year rotation. Option 2, we have just a corn beans rotation, 2 years. And then option 3, we have a corn on corn. Now, multiple studies have been done to evaluate which one of these 3 systems, these 3 rotations, shows the highest organic matter. And here's where the answer usually is pretty tricky. So if I ask most of you participating right now, what do you think out of those 3 systems is the one that is going to have the highest organic matter? And I would like you kind of like think about it for a second. Most of you, I'm pretty sure, are going to say option A, the better rotation, the 3-year rotation. Well, all the studies that we've had about this, most of the studies that we've had about this are actually showing us that option C is the one that gives the highest organic matter. And that's interesting. Why is corn on corn rotation being the one that gives us highest organic matter? Well, there's a reason for that. And the reason is that we actually have more carbon added to that. We know that corn stalks have a lot of carbon. And we know that actually adding carbon to the equation is going to increase organic matter. So is that the right thing? I mean, we were talking about measuring organic matter as being the solution. Well, do we think that corn on corn is the solution for improving our soils and organic matter levels? That's where we really got to start evaluating things. So what if I change the equation? Same studies, same treatments, just then we start changing the perception. What about highest organic carbon and highest mineralizable carbon, which is related to more active carbon, more available carbon for the crop? Which one of those three systems is going to be the one that has the highest organic carbon and the highest mineralizable carbon? And I'll let you all think about it for a second. Again, remember, the highest organic matter usually goes to corn and corn. All the studies shows that, most of the studies. Statistically significant, would say the people from academia. Now, again, which one will have the highest organic carbon and mineralizable carbon? Option A. So then we start talking about available carbon and really the pools that are going to have an impact on soils and plant nutrient availability. So we know this is where things kind of like start differing a bit of how we've managed in the past and how we should think forward. We know that actually systems where we put a lot of carbon, like the corn and corn, might give a little bit of a higher organic matter content, but then the systems where we have more diversity, where we have a better carbon nitrogen ratio, those are the ones that are going to give highest organic carbon and highest mineralizable carbon. And that is what's going to be key for us. So we can say the same thing about cover crops. I mean, this is a talk that people has every day of when they talk about cover crops and what's going to be the best thing for my soil, my carbon, my organic matter. Which one, if we would have two options, and again, for those joining through the phone, we have option A, straight grass cover crops like cereal rye or annual ryegrass, and option B, we have a mix, a 4-way mix, a 7-way mix, any mix that you can add. Which ones do you think is going to have, one, the highest organic matter in the long term, and then which one you think is going to have the highest organic carbon and the highest mineralizable carbon? So based on the example that we just went through, now we can tell that highest organic matter is usually going to go with the one that has more carbon, and that goes to the one species grass, the cereal rye, the annual ryegrass. That's just going to increase organic matter a little bit more. Now, organic carbon and mineralizable carbon, that comes with diversity. That comes with better carbon-nitrogen ratios. So we expect that option B, the one with the multi-species mix, is going to be the one with highest organic carbon, highest mineralizable carbon. So why does that happen? Well, ratios, carbon-nitrogen ratios and diversity of the system is what really does it. We know that soil microbes, microbiological activity has a short carbon-nitrogen ratio. So again, 4:1, 9:1. And then when we go to, again, corn stalks, 80:1, so a lot of carbon, sawdust, 500:1. So when we really add carbon to the equation, yeah, we might increase organic matter in the long run, but it's going to take more energy, more effort for all that biology to actually digest all that carbon. And then even though we can increase organic matter, we won't increase the quality as much as when we have a very diversified, very rich organic matter, organic pool. This is a really nice study that was done and published in Nature that just shows actually, again, for those of you joining on the phone, it's just two different graphs showing the effect of carbon-nitrogen ratios on productivity. And really what it shows is, again, on the y-axis, you're going to have productivity of any crop. And on the x-axis, on the first graph, we have soil microbial biomass. So how many microbes we have in the soil. And the more microbes we have, the better the productivity is. And that talks about soil health. The richer that soil is, the more diversity we have, the more biological activity we have, the higher the productivity is going to be. Now, when we go to the other graph, graph B, then we actually see that, again, productivity on that y-axis, the x-axis, we actually get carbon-nitrogen ratios. The higher the carbon-nitrogen ratio, so the more carbon has that ratio, the more it looks like sawdust or corn stalks, the less the productivity we have. So again, that's where we got to start aiming for something in the middle or to the left side. That means higher biological communities, higher biological activities, but lower carbon-nitrogen ratios. And that is key in order to manage our carbon pools and how we kind of like move forward with our carbon. So how to measure? Actually, the Soil Health Institute, the Tier 1, measure carbons in two ways: soil organic carbon and then short-term carbon mineralization. And that's just rapidly available carbon. It doesn't really tell us measure organic matter because it's so diverse, because measuring that number can be tricky. And you can think actually that, oh, I'm actually doing a lot of things and not seeing a change in my organic matter number. Well, you might actually be changing a lot your organic pools, your available organic N and your mineralizable carbon, but you don't see it reflected in the total organic matter number. Or the other way, you might see a big bump, but the quality is not there. So what you should be looking for is organic carbon and mineralizable carbon. Now, short-term carbon. What is the goal there? Number one goal is to feed that native soil biology, and enhance nutrient uptake. That's what we're going after. So that is really the trick about short-term carbon. Rapidly available carbon is the key, and that's what we are going after. Now, it should be applied with carbon like any other carbon management, again, and then the logistics are the priority. We should try to enhance programs and spoon feed carbon as much whenever possible. So when we talk about short-term carbon, manage it like you manage nitrogen, phosphorus, potassium. Just try to spoon feed that crop. And again, the key thing here is by adding short-term available carbon, we're going to enhance nutrient availability. So add in carbon that is going to feed soil biology will enhance nutrient uptake this season, and we can measure that. So beware of short-term carbon. This is some things to take into account. Feeding the plant versus feeding soil biology. At Midwestern BioAg, we're more about feeding soil biology because that will enhance the uptake of the big five that we were talking. And then some people is more about feeding the plant. Now, the plants need a lot of nutrients. Carbon is more structural. So when you add carbon to the plant, it does more of a hormonal effect. Again, one thing that is key for adding short-term available carbon is the sources. They need to be short bonds of carbon. So they need to be rapidly available for that biology to eat it and then to pretty much enhance nutrient uptake. There is a thing with plant hormonal effects versus feeding the biology. I was just explaining that, and that happens, for example, with humic acids. Humic acids are carbon too, but they're very stable carbon, so it won't have a huge effect on biology. It'll have a higher effect on the plant and a hormonal effect. You just got to know what you're aiming for. And when we have short, rapidly available carbon, for us, the goal is to feed soil biology to enhance nutrient uptake. Another thing to take into account is that carbon, it spikes the system. Short-term available carbon spikes the system. So I call it the Red Bull effect. That's like you give that short-term carbon to your crop, it's going to start respirating more. That biology is going to make everything available. Now, that goes up, that goes down too. If you have 2 Red Bulls right now, I promise you by like 5, 6 p.m., you're going to be crashing. So you got to manage for that. Your crop is going to start performing actually faster, better, but then you got to manage for that. You might have to tweak your nutrient program. You might have to manage for a crop that is looking better, faster, earlier, or you might have to manage for the crash and add a little extra carbon so you don't have that crash. You actually keep it going and enhance the full potential of that crop. The other thing to keep into account is that carbon feeds everything, especially liquid carbon feeds everything. Dry carbon feeds a lot of the biology because you're putting out there. Liquid carbon feeds biology, feeds plant, but it also feeds everything out there. When we talk that carbon feeds biology, we're talking bacteria, fungal, microbiology. Well, diseases are bacteria, fungal, microbiology too. So when you add carbon to a field that actually has a lot of, let's say, fungal diseases, beans that have mold or something like that, it's probably not the best practice because you might feed that disease as well. So one thing we recommend is making all these carbon additions early in the season, or if the crop is completely clean and looks pretty good, because then you can achieve that yield potential. What to measure for short available carbon? Nutrient uptake, and that's what we're all about. We just talk about the big 5 perform better when you have better biological activity. If you're doing anything that improves that biological activity, like adding rapidly available carbon, measure nutrient uptake. That's where you're going to see the best results. That's where you're really going to see the performance. Crop performance, the crop should look better, greener, come up faster, perform better. And then at the end, nutrient use efficiency. How many units of that fertilizer that you're putting out there are really getting into a plant? How many are you losing? And last but not least, the most important, yield, ROI. That's the beauty about short-term available carbon. You can measure ROI. What we do is actually improve nutrient uptake and crop performance, and at the end, you can check that with the yield and compare it to your pocket. Some of the long-term approaches with carbon, it's hard to measure. It's hard to say how much of that I'm really getting back. Short-term available carbon, you should be able to quantify that pretty fast and say, hey, that's my ROI. I'm getting more from my fertilizer. I'm getting more for adding that quick, rapidly available carbon. So kind of like wrapping up our session today with some key takeaways that I want for all of you, and kind of leave some time for questions that you guys might have out there, is 1, you got to manage carbon like you manage the big 5. That is, to me, the key component. You got to manage carbon. We're taking carbon every time we put a crop in and we take the yield out. We got to add long-term carbon. We got to manage for that. Again, quality versus quantity, but we also got to manage for short-term carbon. When it comes to the long-term carbon, quality versus quantity. Don't go for that organic matter big bump. Go for organic matter bumps that actually represent a lot of quality, diversified quality, organic carbon and mineralizable carbon. Short-term carbon, got to find rapidly available sources to feed the soil and enhance nutrient uptake. And you got to measure that. And you got to measure nutrient uptake, crop performance, and then ROI. And then look for easy fits. You don't have to change your whole farming operation to improve it, to add carbon. Actually, try to enhance the program. Every time you have a liquid or a dry application, you can add carbon to it, do it. There are lots of sources out there. There are some really good ones. There are some that are okay. But again, every time you're going to add carbon to the equation, you're going to improve your program. You're going to improve your crop. MBA, this is going to be the only commercial slide I have there. We have the best carbon-based fertilizers, and I can say that actually very proud that we have the best dry and liquid carbon-based fertilizers. Not only I say it, there are some testimonials here on the screen that you can see. Again, guys that have used it, they talk about, again, increasing biological activity, but at the end, increasing bushels. And what they see, 25, 30 bushel yield advantage. How actually micronutrients uptake. They actually say, hey, we added carbon, we get better. I mean, Marvin Wiles, higher nutrient levels at VT that led to a bushel increase. So they actually see it. And that's what we do. So if you want to know more about carbon-based fertilizers and what we do, feel free to contact us. Feel free to visit terranu.info and what we have on the dry and the liquid side as well. That said, I don't want to hold you all for too long because we have to stay under 30 minutes, and I promise we're going to have some time for questions. Thank you. Stay safe with all this COVID-19 mayhem, and have a blessed Easter. So I'm also going to leave this slide up here, which has, again, the email for submitting your name and your CCA ID so we can send the credits and you can get those credits. And then last but not least, we can have any questions that you guys might have about carbon, about really soil health and carbon and nutrient uptake, and about anything that we do. This is kind of like a good time to do that. You can put those in the chat. You can send them to our email. You can send them to our Facebook. And we can leave this open for a little bit. So let me see. We have a chat open here, and I'm not gonna say who. It's anonymous, so I'm not gonna read who asked the questions. So feel free to ask. What methods do you recommend for measuring nutrient uptake? That's a great question. So really, tissue samples. Those are great ones to measure nutrient uptake. We actually at MBA, our protocols when we evaluate our carbon-based fertilizers, kind of like evaluate the whole season. So we do early season, mid-season, and late season. The key thing there is being consistent, and then to compare A to B. So what we do is we compare a system that has our products or a carbon-based approach versus the same program without the carbon too, and then we just measure nutrient tissue content. So we do at early V4, V3, V4, we do mid-season V6, around V6, and then we do late season, this is for corn, VT. So then we can see actually the nutrients we're getting into the crop, we're getting there, and we're translocated into that grain and then crop performance. So to me, the key is to measure it. The best methods to measure that when it comes to carbon is going to be, again, tissue samples I recommend, and at the end yield. That yield is going to be it. The other thing that we can measure is quality of the grain. We do see a lot of times that impact on the quality of the grain. So when sometimes you measure grain quality in corn, in beans, that's when we see a lot of the nutrients uptake too performing. A lot of the times we just go with yield, but then the quality of that grain, how good it is, protein content and everything that we do, when you add carbon to the equation, you improve grain quality as well. Okay, let's see, we have another one. What is the carbon content of Terranu? Just to give you guys an idea, briefly without getting too commercial in that one. Terranu, any formulation that we have, is about 40% carbon base. It has the 40% of the carbon matrix. That carbon base is about 70% organic matter, and more than organic matter is rapidly available carbon because it comes from a digestion process where we almost harvest the top quality of a manure digestion process. So really it's rapidly available carbon that feeds and stimulates native soil biology. What is the best way to bounce back soil biology after long-term anhydrous applications? Great question. One thing, and again, best way is a systems approach. So you got to manage different things. That there's no kind of like no trick to that. You gotta really improve a lot of different programs. Now, my approach is the easiest first step to take is to add carbon to your program. Start feeding your native soil biology. I worked for many years in the potato industry, and potato fields are by far the worst fields, quote unquote. I'm going to say it because they're good fields you can produce that you have out there. I mean, I say that because they are sandy soils, low CEC, low organic matter, below 1% everything. So these are really hard soils to work with. And still, when you add carbon, you can feed native soil biology. And to me, seeing that in soils that are almost, again, sandy soils with very low organic matter, CECs, et cetera, that's the best way. The adding rapidly available carbon that is going to stimulate that native soil biology and diversify your biological activity, I think is the first step. I call it like tuning up the system. So again, that's just like cranking up your local system, your motor, to actually then get started. So to me, that is probably the best way to get your system cranked up. It's adding rapidly available carbon. Then you can start thinking about managing the long term. So then you start thinking about, again, compost or adding biologicals and more biological management, manures themselves, and other things that are going to help you more in the long run. But again, to me, the key thing about short-term available carbon is that you can measure it. So any system that you have right now, you can enhance it by adding carbon to it. And again, you have carbon-based fertilizers now on the dry side, on the liquid side, that you can measure. You can go ahead, add it, and measure that. Let's see, more questions. A few more. Okay, any more questions that you might have? And if not, we would finish right on time. But yeah, bouncing back soil biology is it's going to be interesting. It's tricky, but to me, more than going for a silver bullet, is feed that native soil biology. Any soil out there has a lot. I mean, it's 2 million microorganisms in a tablespoon of soil. So think about all the biology that you have out there that you can feed and enhance. So by adding rapidly available carbon, you're just going to really start cranking up that system, tuning it up, and make all those nutrients that you already have out there more available. To me, that's the first step, getting everything active. We talk about adding stuff. I think making that biology active is what's key. And you can measure that relatively easy. When we were talking about measurements, there are a lot of easy measurements. I mean, one that I laugh a lot, but it's a good one, is the underwear test. When you add carbon to equation, when you start doing all these things that really start helping your soil biology, you can grab some old underwear, and trust me, the wives are usually happy when you do that because you get rid of old underwear. And if you bury underwear, cotton underwear, in your fields, and you have, let's say, treatment A, where you had your carbon-based fertilizer or your amendments, and treatment B, where you didn't have it, and then you bury cotton underwear, and you bury that early in the season, you come later in the season where you have more biological activity, that underwear is pretty much gone, it's chewed up. Where you don't have it, those are there almost intact. So that's an easy measurement. I mean, there are other measurements. When we were talking about the soil health tier 1, organic carbon and mineralizable carbon, those are rapidly available sources of carbon that reflect changes. And most labs know how to do that. They just don't do it because most people ask for organic matter. And we already talked a bit about the problem of organic matter and going for that number and thinking sometimes, oh, I'm not getting there. Or the other way, getting a big bump and saying, oh, great, I'm doing great things. I always tell the joke that the easiest way to increase organic matter is to switch labs. Because really, you go from one lab to the other, and not to have anything against or in favor of a specific lab, but a lot of all the labs, when they measure organic matter, they're off within themselves. So if you grab your same soil sample, send it to a lab, it's going to be a 4. Then you send it to a different lab, it's a 5. So there you go. You can celebrate. You just increase 1 point. And again, that's not the trick. The trick is diversity and how rich that organic matter really is. Okay, any more questions we might have before? If not, we can call it. I mean, it was a 30-minute session. Finished right on time.